I'd now like to thank and acknowledge our sponsors. We are delighted to welcome a new sponsor today, the Voting Voices, as our new bronze sponsor. The Voting Voices include our very own Lori and Richard Wack, and former presidents Charlie Williams and Michelle Levy. They are joining David and Lynn Berelsman as our bronze sponsors. Please join me in thanking them for supporting this event. And if David, Lynn, Michelle, and Charlie, if you would stand. And if Lori is listening in on our YouTube channel, thank you all. It's also my pleasure to again welcome and thank Jeff Cowherd, the Executive Vice President of Lending for Climate First Bank, and his team for supporting this event as a platinum sponsor. Jeff, if you would please stand to be recognized. Thank you. The mission of Climate First, which is so appropriate today, is to do the right thing for the planet, our people, the community, and their shareholders. As a mission-driven organization, Climate First is honored to sponsor today's event and understands that conversations like today's are more important than ever. The bank offers a range of products, and you can speak to them today about how you can use your finance as a force for good. Thank you. We are so fortunate to be sitting inside for today's event. And for me, I'm so fortunate because my air conditioning just went out. This summer, Central Florida, along with the rest of the world, has experienced record-breaking heat. We escape those temperatures by staying inside, but it is taking more and more energy to keep us cool within our buildings, our homes, our offices, and retail. So what does the future of our climate have in store for us on this planet? Well, a new space race has begun. Instead of going to the stars, it's a race to reimagine the Earth's spaces, the infrastructure where we work, live, and play. Climate change is upon us, and building innovation must move beyond where we are today, from concept to a new reality. As Central Florida endures record-breaking heat and soaring energy demand, the Hot Topics Committee and the Natural Resources Clean Energy team put together today's program to discuss a path forward. We have a stellar panel to discuss how new construction and improvements to existing buildings can dramatically reduce energy use and help us save the planet. And as we begin this conversation, we send a bouquet of gratitude to Mary DuBois. Mary is the chair of the Energy Subcommittee for Natural Resources, and she organized today's event. To lead our discussion today, we are pleased to have George Waldenberger as our moderator. George grew up in Wisconsin and moved to Orlando to escape the winter weather. Little did he know. George he's worn many hats. He's been a farmer in Wisconsin, a geotechnical engineer for a company that helps design skyscrapers in New York City. And for the past 10 years, he's been a meteorologist at WFTV. Here, George scans the sunny skies, and he tracks hurricanes and tornadoes. He's even gone so far as to join the hurricane hunters in missions with hurricanes Irma and Dorian. George has a wide experience in science reporting across Central Florida, and he's covered everything from rocket launches, coastal erosion, sinkholes, flood mitigation, to solar energy technology. Let's give an energy-filled, warm welcome to George Waldenberger.
That was a warm welcome. But thanks for coming on the hottest day of the year to this fascinating event. And by the way, today is the first day we've ever had an excessive heat warning issued for Orlando. Today's the day. They've been around for 15 years. Today's our first. And if you've noticed, the last few nights have been really steamy. Have you noticed this? You know why this is happening? We've been reporting that the water temperatures in the Gulf of Mexico and the Atlantic and South Florida have been much hotter than normal. Well, those are supplying the atmosphere at low levels with heat and extra moisture, and you're feeling it. So everything's kind of related, and that's why the subject of sustainability is important. It impacts us all. So let's start by introducing some of our wonderful panelists. Let's start with Ashley P. Van Stone. She serves as the Sustainability Manager for the City of Orlando's Office of Sustainability and Resilience. This is where she coordinates the city's clean energy, green buildings, and transportation efforts. She has over a decade of experience and expertise in sustainability strategic planning, project management, assessment and evaluation, stakeholder engagement, and community outreach and education. Philip Ferry. He's been the Deputy Director of the Florida Solar Energy Center since 1990. Prior to assuming the Deputy Director's position, he spent 10 years at FSEC conducting research in buildings and energy efficiency. He conceived and developed the Florida Building Energy Efficient Rating System and led to the development of the Energy Gauge, which is a user-friendly software tool for code compliance, energy ratings, and economic analysis. Philip has more than 40 years of experience in the building science research area. We have Lisa Piercy. She's an advocate for clean energy and energy efficiency and the owner of 15 Light Years. Her passion lies in educating and raising awareness about solar energy's potential to transform the way we generate energy and electricity. Lisa's primary focus on sustainability has led to significant achievements in the solar industry. Her company successfully installed solar panels on Orlando's first zero energy building, showcasing her commitment to advancing renewable energy solutions. Lisa played a significant role in establishing the Green School program at Orange County Public Schools, which promotes a comprehensive approach to sustainability, school ground enhancement, resource conservation, curriculum connections, and community involvement. And we have Philip Donovan. As an architect, is a national director in regenerative design and a member of the Regen Collab with Little Diversified Architectural Consulting. Philip's experience over the last 20 years has been deeply rooted in the design of high-performance, zero-energy, regenerative built environments that are focused on health and well-being of building concepts, bioregions, and social communities. They are deeply interconnected as well. He served as a project architect on 5 net zero energy schools, including Neo City Academy in Kissimmee, Florida's first zero energy school. Philip is also a member of the Florida State A1A Advisory Council on Resilient Design and Green Energy Task Force for Miami-Dade County Public Schools, and a member of Orange County Sustainability and Resiliency Committee. Please welcome our panelists. And as a reminder, each question is 2 minutes to answer, and we will be firm on those 2 minutes. Okay, so let's start with the first question. Are we ready? Okay, this is for everybody, roughly 30 seconds each. We'll just go right down the row. If buildings account for 75% of electricity generated and 40% of emissions, very briefly, describe how your work involves buildings and how you can contribute toward turning them into so-called superhero buildings.
Sure. So within the city of Orlando, our built environment actually accounts for roughly 80% of our total carbon footprint. So it's the vast majority by and large, followed by transportation. Obviously, we have some of our own city facilities that we have direct control over that we can make improvements to and lead by example, so we can try to set that bar. And then I'll use everyone's favorite word. We have policy mechanisms we could use, incentives and other tools that we can implement to try to spur that change at scale.
Okay, thank you. Philip Donovan?
I think we need to get back to education and start with the why. Right? Why are we doing this? Because we need to get back to living in harmony with nature. We used to be in balance, and we've tipped to a critical unbalance. And so while I work every day, put my architect hat on to create better performing buildings, which would result in better performance of people and places that inhabit those buildings, we really need to educate, right? I can design a great building if you say so, but that building has a lifelong after the design and construction of it. And so we've got to continue to educate and advocate.
Yeah, at 15 light years, we're often known as the boots on the ground, the operations, but a lot of what we do is community advocacy. We work within different communities. We reach them in ways that somebody as a local installer can. With the co-op, we're going to be going over 200 homes. Having that privilege is a really good opportunity to kind of discuss what people can do from the ground up.
At the Florida Solar Energy Center, we've been studying renewable energy and energy efficiency for the last 40 years. And so basically our task is to develop the technologies that move the industry forward and move the environment forward. And so that's essentially what we've been doing for the last 40 years as a statewide research institute.
All right, so we have policy, we have education, we have community, and we have technology. I'd say we're a well-rounded panel up here. Okay, let's go on. Philip Ferry, what do the terms zero energy, zero carbon, high performance, what do these terms mean when it comes to buildings? Are they based on the concept of the building's energy used as offset by the energy it produces? And how can prospective home buyers determine if the home that they're considering qualifies for any of these monikers?
Wow, what a question. That's a big one.
2 minutes, please.
Well, thankfully, we actually have American national standards that define a number of these terms. For example, zero energy has a definition within American national standards that basically say that the building produces as much energy as it uses over the course of a year, and they call them net zero energy buildings. And these can be residential buildings or they can be commercial buildings. Now, when we get to carbon, we are starting to get a lot more attention on net zero carbon. And I want to be very clear that net zero carbon is not net zero energy. And there are very good reasons for this, and most of them have to do with the way emissions from electrical power generation occur. And what happens is there are more emissions from electrical generation during times of the day when solar energy, I said that wrong. There's less emissions from power generation during times of the day when solar energy is very prevalent. And so things like PV are operating during periods of the day where the emissions from generation are quite low, but at night when there is no solar generation, the emissions are higher. And so while you've got a kilowatt hour is a kilowatt hour no matter what time of day it is, the emissions are different depending on what time of the day it is. And so net zero energy is not net zero carbon, but we're headed towards net zero carbon. And there are ways to evaluate this. One of the ways is through what are called home energy ratings. And this will tell you how good your home is with respect to a standard. It's an American National Standard reference case.
All right, Philip, I think we're at the end. Thank you. All right, let's move on. Philip Donovan, on a larger scale building, what are the key components of reaching zero energy and zero carbon status? And what are some examples of successful buildings that show success in the long term as far as money savings in maintenance and operation of these buildings versus what was originally spent to design those features? And then are there any examples where buildings have tried and failed?
Who likes to talk about failures? That's where we learn the best, right?
Absolutely.
I don't know that buildings fail. I think expectations of buildings fail. I think the way that people use them and inhabit them without understanding the goals there, especially as we shift to this carbon neutrality. Philip did a good job of starting to explain that. But zero energy means I'm offsetting my energy footprint, right? Zero carbon is so much more. It's tied into the cycle of life of that building. One of the greatest superhero buildings is the one that's already built, the one that we re-inhabit, that has a change of use. If we never designed and built another building, if we inhabited the stock that we had, we would be so much further along because carbon is embodied in that building we've already built, right? So we need to re-inhabit places where we've been, and we need to get back to finding that balance. What it really comes down to is any building is zero energy ready, right? If you have a solar array big enough, this building's zero energy ready. If you have a solar array big enough or a wind farm big enough to offset it, what we have to do first, 80% of the savings is reducing the energy use, and we can do that on every building, every time, and every design. And if we put solar panels on it, we use a lot less of them when we reduce that energy use down to offset its footprint. So that's the key in what we're trying to achieve here. First, let's get to energy efficiency that's deeply rooted in the operations, that's successful long-term. And then let's offset it with renewables like what Lisa does and understand and keep educating people on the importance of that and why it happens, why it needs to happen, and how we continue to exist in those buildings long term.
All right, thank you. Ashley, how has the city of Orlando improved the performance of its own buildings, and what goals has the City Commission adopted regarding emission reduction and the use of renewable energy community-wide? One more question, what are the current requirements for new construction?
Sure, I'll start with the goals. We've set a few ambitious ones that are actually part of our municipal code, putting sustainability as really a tenet of what the city aspires to. So for city facilities, we're aiming to have all of those run on renewable sources of energy, which here in Florida is primarily solar at the time, by 2030, so just a few short years away. And then by 2050, we have that goal to be citywide, so any operations within the city to be running on clean sources. We also, as of 2012, have a requirement that all city-funded facilities have to have a LEED Silver minimum standard of green building design and operation. And then a few years ago, we actually established a green building incentive that's available for private new construction development within the city. So that's essentially a property tax rebate based on your LEED level of certification. Really give it to our facilities and energy management team, who we have some of them here in the room today. Starting in 2010, we leveraged green bond financing and invested about $17.5 million into our existing facilities to really improve their performance. And that's resulted in an average of 23% annual savings per year, which equates to about $2.5 million each year. So now that allows us to reinvest that money back into further improvements. And one of the more exciting projects that we have underway right now through some grant funding from the federal government is to actually convert a handful of our community and neighborhood centers into resilience hubs. So this is largely looking at on-site power generation, HVAC and air conditioning improvements, and air filtration to make those spaces even more resilient in the face of storms and other types of shocks and stressors to our community, and making sure that we can activate them in all sorts of moments when we need to better serve our residents in those times of duress.
Okay, well put, thank you. All right, the next question, Philip Donovan and Lisa, let's explore what is different about high-performance buildings. During the design and construction phase, how is the approach to a high-performance building different from a traditional building? And Lisa, you can start.
So there's an integrative design process, which is very different than the traditional process. And honestly, the biggest thing is just listening to the stakeholders, listening to the users, A lot of people like to talk, but a lot of people don't like to listen. And usually asking them why, like Philip said earlier, why are they here? And the person in the room that says, because I have to be, that's the person you want to listen to, because that's the person you're going to want to change their mind and feel like you did a good job collaborating with them and listening to them. There's a lot of stakeholders that you really need to consider. No one knows as much as everyone, so we need the facilities person who's going to manage the building. We're going to need the users. We're going to need the building owners who are going to have a cost concern. And that conversation needs to happen, and everyone needs to collaborate in a workshop before the design process even starts.
I think I would add, Lisa hit on it, the integrated process. We need to get back to the old ways of designing and building where we had a relationship with our contractors and we understood each other. We also need to understand how buildings use energy, right? And for a long time, we never understood that. So as an architect, I would ask an engineer to give me some air conditioning. Let's make sure everybody feels comfortable. But our engineers never knew exactly how the building was performing, right? So we optimized systems. We had redundancy in there, and everybody's really comfortable. But as George did a good job of saying, it's the hottest day of the year. We can't continue jacking up the AC and expecting we're going to continue business as normal. So it's an integrated process, and we're looking to drive that energy use down, right? We're looking to model data, use data. We have access to it in all kinds of ways to optimize every single resource we put in that building and its use of resources long term.
Okay, thank you. Lisa, how can building users be involved during design, construction, and occupancy phases?
So obviously during design phases is really listening to the users and the end result of the building. Everything is a part of the integrative design process, from the flooring to the acoustics to the lighting and their comfort level and their use. So obviously you're not going to put a bunch of stairways in a building that's going to be used by handicap accessibility, having issues with that. So you have to think about every part of the process and listening to them, but also in the training and education. So if people don't know how to use all this high-tech technology that's out there and no one understands it, it's not going to be used properly. And a lot of times it will be overridden by the user and then not function, not only not properly, but worse than maybe a traditional system would have operated. So lastly, you need to maintain an eye on the building. So you need to verify that the building's operating properly through data, monitoring, and conversations. Again, just having conversations with the people. If there's, things going on in the building that they see or, feel, that they can express that to you, and you can you can redirect next time, and you can always look back on making amends with whatever you did wrong, because we learned from our failures, like you said.
Absolutely, and honing the process. Okay, Ashley, Lisa, solar panels are often the first thing we think of when we think of high-performance buildings. Do all high-performance buildings have solar panels on their roofs or nearby? And how much of the equation of becoming a so-called superhero building involves solar panels directly versus using solar energy produced from elsewhere? That's for Lisa and Ashley.
So I wish all buildings had solar.
Sure.
That being said, we started with humble beginnings. We used to do insulation, worked with Duke Energy. We look at a building holistically, and we really focus on energy efficiency first, and that's why we brought solar to the market at 15 light years, because we really started in the efficiency space. And like Philip said, if we don't have efficient buildings and we just put a bunch of glass on buildings that are maybe in shade, there's a lot of buildings that we can't put solar on. There's a lot of variables that we have to consider. So in those cases, we can really hone in on energy efficiency. Reducing the size of the HVAC system through shading can be a huge, huge benefit to a building.
Well, Lisa, you really kind of teed it up well that, we have that efficiency first approach at the city and really trying to get our buildings to operate at that optimal performance and understand, is it going to need a new roof soon? It might not be the best candidate for a solar project. But our strategy is definitely the combination of what you said in your question, that where it's possible and feasible to do on-site installations, that's what we're pursuing. But some of our facilities, that's just not the right solution. So we do subscribe to utility subscription programs for our solar, both through OUC and through Duke. A few years ago, we also worked with the National Renewable Energy Laboratory to develop a solar roadmap. So look holistically at our building stock, understand like what are the right criteria to determine feasibility, and then we use that now to prioritize projects, to advocate for capital improvement funding so we can pursue those projects. And this has actually influenced how we're designing our buildings. So to some of your points, Philip, about architecture, I mean, we are designing our fire stations differently. So those roofs are flat and really maximize that solar capacity versus some of our older ones that have more of a pitched roof and just a different architectural style. So where can we make those, changes and decisions earlier on in the process to make the most of those opportunities? I'm happy to say that since 2019, we're using 5 times more energy between our on-site and off-site solar subscriptions, it's roughly a quarter of our total energy portfolio. So a lot of progress in a short amount of time, but definitely still a lot more to do. So.
Okay, thank you, Ashley. Lisa, do buildings impact our health, our comfort, our moods? How do high-performance buildings provide benefits of better health and human performance?
So again, touching on natural light and views, as I look at the lake, it just makes me happy to see it, to see green space. So anywhere from the location of your building, making sure you have transportation nearby, making sure you have green space nearby, to indoor air quality, which was a big one these past couple years, right? So a lot of people redirected and refocused on indoor air quality. And then, thermal comfort, of course, is a huge one. You see people in offices all the time with like the heater, the space heater underneath their thing. So, being comfortable in your building and being happy can go hand in hand. So that's really important. And then the biophilic design now is a pretty big thing, and integrating plants into your design and allowing people to be able to breathe fresh air. It's something that we don't take for granted anymore. As well as active design. So again, if you're going to have an active, user, then you're going to want to create active design, give them space to get up and walk around, and just putting all of that into consideration when you're building.
Okay, thank you. Ashley, this is an important question. Income-challenged residents are often disproportionately impacted by poorly performing buildings. What programs are available to help low-income homeowners improve their homesteads? And how can landlords be persuaded to make energy and water-saving improvements for renters that cannot make those decisions?
Well, your last question is really the million-dollar one that we're trying to answer here at the city. About 65% of Orlando's residents are viewed as tenants. So understanding that kind of split incentive and figuring out what mechanisms we could put in place to encourage landlords to make those improvements is something that we've been actively exploring for a number of months. In 2021, we conducted a study on energy burden. So for anyone who's not familiar with that phrasing, energy burden is just looking at the percent of income spent on energy bills. Anything that's 6% or higher means that that person and that household is living in a state of energy burden. And energy inefficient housing is a major factor. So here in Orlando, I know we're in Winter Park, but Orlando over yonder, the energy burdens are about 130% higher than the national average. And those that are in that top 5% of burden tracks, the average burden level is 9.2%. So that's actually getting to what's considered a near level of severe burden, which is at 10%. So last year we launched an energy burden task force at the city. It's comprised of a number of representatives across different departments as well as members from OUC. And we're really using a human-centered design methodology to engage with residents early, often, understand the problem on a more qualitative level since we have a quantitative sense of what it looks like, so we can understand the utility programs that exist to assess and improve your home. Are residents aware of them? How accessible are they? How can we improve the efficacy of those and get more residents taking advantage of them? And then to your point, the big landlord question is one that we're still welcoming input, feedback, ideas on, because that is probably the biggest challenge when we think about multifamily housing and that relationship.
All right, thank you, Ashley. This question is for everyone, but we'll start with Philip Ferry. Let's unpack high-performance buildings and how various components are treated differently in high-performance building. What's different about the building envelope? What's different about the heating and cooling systems, the lighting system, the orientation of site and passive design, and how is solar incorporated? Philip?
Okay, we'll take them one by one. What's different about the building envelope? Well, high-performance buildings have building envelopes that avoid solar absorption, for lack of a better term. They don't want the sunlight to heat up the building or the occupants within it. And so that's one of the critical components, and we now have outstanding fenestration systems, windows and doors, and that don't allow very much heat to come into the building. There's a concept called solar heat gain coefficient. It's gotten very, very low in glass, and so only about 10 to 20% of the heat that is coming in with the sunlight is bringing heat in with it. Heating and cooling systems have come a long way in the last few years. We now have heating and cooling systems on the market that have cooling ratios. They're called SEER, seasonal energy efficiency ratios, on the order of 20%, and heating ratios are on the order of 20, which is, an expression of how efficient it is. And the minimum requirement is 14, and so if you've got 20s in your building, you're a heck of a lot better off than a 14. And for heating, we've got equipment that is as high as 10 and a half, and the minimum requirement is only 8, and so you're a lot better off with the 10 and a half than you are the 8. Lighting systems are fantastic nowadays. LED lighting systems are phenomenal. They provide tremendous amounts of light at very little electricity use. And so the lighting systems in buildings today are substantially better than they were as little as 10 years ago. Passive design. Let's talk a little bit about passive design. If you can do it, it's a good idea. There's a number of months in Florida where it's wonderful outside, and so you want to have a building design that allows you to bring the outside inside, and so you can connect better with the outside. And so things like operable windows and better ventilation systems and natural ventilation systems in buildings can be very fortuitous for most of the year in Florida. And since the windows are so good, you don't have to worry quite as much about having more windows.
All right, thank you, Philip. I'll stop you there. I think we talked about solar a little, so we'll move on to the next question. That was very, very thorough. Philip Donovan, net zero schools have been built by a variety of school districts. Why school districts? Is Florida a good location for this, and what lessons have been learned?
Florida's a good location for any zero energy building. But schools in particular face tightening budgets. And here's the secret. We're not doing anything different when we create vastly different than what has transpired before. We're not instituting vastly different building systems, envelope systems, or mechanical systems. These are things that are prevalent on the market, that our schools are being built with. We're forming relationships again with our contractor partners to understand how buildings to go together in a different way, a little bit different way, and a lot of that comes down to quality control. And then we're engaging with the curriculum. We're engaging with that user group. Who here has hyperventilated before, right? And you breathe into a paper bag. You do that to poison your brain a little bit, to calm you down. Well, Lisa talked about indoor air quality. CO2 has been a nightmare in schools for a long, long time, and we're asking our kids to test better, to do better. Teachers, step up and elevate performance, and we're not giving them, for a long time, the conditions in schools in a lot of places were bad, but we really didn't understand what that meant. And so ventilation becomes a big part of it. And of course, we're in Florida, so we're going to pull in a lot of hot, humid air. Well, when we do that, we got to pull the moisture out. So we're optimizing things. When we pull that moisture out at condensate, we're putting it back into cooling towers, right? That's a couple of $1,000s on a $20 million building to reduce the cost of pulling water in from the utility. So schools are looking to optimize the ways that we put buildings together, and then how do we make operations and long-term maintenance as effective and efficient as possible? Whether it's staffing issues or just the amount of schools we're building now, we've got to optimize things in design and construction, and then in the long-term operations and maintenance so it's sustainable and thriving, and the people in those buildings do that. So with schools in particular, there's a look at how do we elevate performance in the school, and how do we tie that into getting a cost-effective, efficient high-performance building envelope, and so schools
Thank you,
need
Philip.
to do that. Yeah.
Okay, good answer. Philip Ferry, next question. Our metro is composed of thousands of existing buildings built traditionally. How can existing buildings be retrofitted to become high performance? The Florida Solar Energy Center conducts building research and provides unbiased findings to identify the most effective practices for improving the performance of buildings in our humid climate. So when the center studied energy efficiency options for affordable housing, what best practices brought existing homes to be on par with newly constructed high-performance homes?
Well, retrofits in general are problematic because they are more expensive than doing it right the first time. And so that's kind of a problem. But there are a number of areas where the technologies and the ability to do something about problems in buildings are particularly effective. One of them is something called duct leakage. We find that in many existing homes, especially older existing homes, the ducts that are carrying the air conditioning from the air conditioning unit to the various rooms leak fairly badly, and that produces a lot of unnecessary inefficiency, for lack of a better term, even for efficient air conditioners. And so we can make a lot of progress, and there are test methodologies to test how much ducts are leaking in buildings. And we can also test how much envelopes are leaking in existing buildings. And so reducing envelope leakage in buildings and reducing duct leakage in existing buildings is a critical piece of moving forward. The other thing we can do is where we don't have buildings insulated as well as they should be, particularly in attics, we can add insulation at reasonable cost. The next thing you can do is you can make significant improvements in the efficiency of equipment. Now, about 7 or 8% of the air conditioners in Florida get replaced every single year. Instead of replacing them with what comes off the back of the truck, we could replace them with air conditioners that are much better than the minimum efficiency. And we could save a lot of energy there. And that's particularly important in low-income housing, where the energy bill can be extremely large, and having a little bit of an investment on the front end can make a large difference on the back end.
Okay, thank you very much. Lisa, as someone experienced in both commercial and residential projects, could you provide insights into key strategies for achieving high performance status in residential buildings? How do these strategies differ from those applied in larger buildings? For homeowners who are enthusiastic about enhancing their homes' efficiency, what are some more straightforward steps to move closer to high performance standards? And could you outline practical approaches for building owners and operators, highlighting the process to improve their building performance, and are there any resources that they can take advantage of?
Yeah, absolutely. So the main difference is the different stakeholders, right? When it's your home, you can put a little more time and consideration into it, and there's less users. So that's probably the main difference. Obviously, you can still apply a lot of the LED lighting, energy efficient HVAC. You can still do insulation, whether it's a residential home or a commercial building. You can still use passive design strategies if you have an opportunity to build your own home. But one of the first things I would recommend to homeowners is to do an energy audit. The city of Winter Park offers them for free for Winter Park residents, as well as if you reach out to your local utility, AUG offers a vast amount of resources to its clients, and then the local utility programs and rebates, so you need to look into those as well. Once you have that energy audit, you're looking at the low-hanging fruit in your home. Every building's different. Somebody may need windows desperately, and somebody may need new duct work or repaired duct work. And so then you'll know where to start and what's going to have the most bang for your buck, especially when resources are so limited right now. And then, government programs, obviously, if you decide to go solar, you have the resources or the right building for that. There's obviously the investment that you're going to make. You get 30% back for the tax credit. And then there's online resources. We live in the time of information, and sometimes it can be almost too much information. So going to resources like League of Women Voters, that's a great start, so they can kind of narrow it down for you a little bit, because it does get overwhelming. It gets overwhelming for me to keep up with the technology. I kind of feel like, my 15-year-old's way smarter than me already. So we have to go to the young people too, and to talk to them about, ways they can do things, and in the school systems, and start there. So I think that's really what we can do as individuals.
Okay, thank you, Lisa. Very, very well done, well answered. Philip Ferry, I think this question is very interesting. What are a few points learned from software simulations as efficiency of certain strategies that are used for buildings to become superhero buildings? What are some of the new areas of interest that are showing potential for future development to be part of the toolkit to increase energy efficiency? And do you see emerging trends that could improve the performance of buildings, and any local examples of that?
Well, again, there's a lot of improvement that has been made with respect to software simulations of buildings and modeling buildings. And so one of the things that we learned from doing simulation models of buildings is what are the best code options that can be implemented within building codes. Other kinds of things that we learned from doing simulations on buildings are what are the most cost-effective things that we can do with buildings, and how can those best be implemented in both the residential and the commercial building sector. And what can we do in terms of subsidizing things that are more important than other things, because one of the things that comes out of building simulations is basically a list of priorities. Where is the energy being used, and how is it being used, and what can we do to attack the largest energy uses and get the low-hanging fruit first rather than trying to do everything. One of the other things is that building simulations are now being used to evaluate buildings for things like the Energy Star Homes program and the DOE Zero Energy Ready Homes program. And so you must use building simulations to determine the qualification for those kinds of programs. And this is becoming increasingly important because there are tax credits associated with both of those programs. Now, the the IRA, Inflation Reduction Act, put in place a number of different tax credits within the building sector. They're not only for photovoltaics, but they're also for other kinds of things like high performance air conditioners and heat pump water heaters, which are very interesting, by the way, because heat pump water heaters cool your house, heat your water by taking the heat out of your house and put it in the water tank. And so they're very interesting kind of things. And that's, if you get the right kind of heat pump water heater, you get a 30% income tax credit for that. And so there's a whole host of things that are now available, and simulation software is critically important to qualifying for a lot of these programs.
Okay, thank you very much. Now we'll move on to our lightning round question. 15 seconds each, but I may give you a few more seconds. I'm feeling liberal today. Each panelist will go down the line. 15 seconds is the goal. But what is the most important part of this conversation for League members and others as takeaways to learn or to join with you as part of the solution? Ashley.
Hosting events like these, increasing education, voting for the leaders that are going to pass the policies. I mean, policy is just a really important tool to really do things at scale, and I'll leave it at that.
Okay, thank you. Philip Donovan.
I would say, what are we each personally willing to do? How are we willing to invest personally in this effort? My company, Little, has said we're moving towards regenerative design, but can we get everybody, all 400 employees there? Only if they're willing to do that personally. And then, are we all able to foster empathy for future generations? And not just the human species, but all species, because we're all interconnected. Life is all interconnected, and we got to keep focusing on that.
Yeah, I would say listen, learn, get curious. I mean, getting curious is probably the most important thing, because I think sometimes we focus too much on perfection, or, oh, I'm not green enough, or I don't understand enough, or I don't understand the technology. But it's, as soon as you get curious, you'll see all the resources out there to support you through that journey.
I think I'm going to throw my prejudices here. Efficiency first. Do all the efficiency you can possibly do, and then add as much renewables as possible to get to net zero. It's really important. Do it.
Wow, that's good. Do we have any extra time? We do. Okay, so what I'm going to do is, I had to interrupt, and I really feel bad about that, a couple times. So we'll go back and we'll revisit the times I interrupted. And the first time was Philip Ferry. You were talking about how homeowners, they could take advantage of, they could find out if they were interested in buying or purchasing energy efficient homes. And you started talking about the energy guide. Was there anything else you wanted to add about that?
Yeah, let me just go a little bit further. There is, an ability to determine the performance of homes, essentially. And it's called a home energy rating system. And it basically takes your home or any proposed home and determines how efficient it is, or what kind of performance it has with respect to a standard design or a reference case. And right now, the Florida Minimum Code has scores on this scale, and 100 is the top and 0 is zero energy. And right now, the Florida Minimum Code homes are right about 60, 66 on the point scale. If we start to talk about what can be done, and some of these programs that are providing tax incentives to builders, and as much as $5,000 in tax incentives to a builder for a house that gets to the DOE's Zero Energy Ready Homes qualification. That's a substantial amount of money. But if we talk about those kinds of programs, it drives that number all the way down from about 60 to the mid-40s. And so that's a big change. And anybody who is purchasing a new home can ask their builder whether or not they have had a home energy rating done on that building. And if they haven't, they're probably building to the minimum code. And if they have, they're probably building beyond that minimum code, because there's a large number of major builders across the United States that are building much beyond minimum code using this home energy rating index to determine where they stand in the marketplace for buildings.
All right, that was very insightful, thank you. And then we'll go on to Philip Donovan. I asked, or you had mentioned, what better way to learn than to fail, right? So what are some examples of ideas, maybe in recent history, that have been implemented even, and that we've since recently discovered they just don't work? Anybody can jump in on this too if they want to.
This is a good one. I gotta shift to the fact of, we've been moving to energy efficiency for a long time. LEED came out in 1993, I believe, and it did wonders for us, right? But a lot of the things that we have implemented in design and in construction and turned over, we've never followed up on. How is the building actually performing? I do an energy model, a simulation that says my building's gonna do this, and I never, my profession especially we don't like to look at failures. That's a great building, thank you, let me go to the next one. But we gotta understand how people use buildings. I can't carbon copy a building from one user group to another and expect it to operate the same way. So we have to start to design, not in prototypes, but in specific places and for specific people and for specific climates. And I wanted to take just 1 minute to talk a little bit about, we've mentioned carbon a couple times. We've talked a lot about energy, and energy is part of that story, but carbon, Philip laid it out very, very well. They're two different things, energy and carbon is the building block of all life, right? And all the carbon we have on Earth is all that we've ever had. We're just shifting it from one place to another. And in fact, we're moving it into the atmosphere where it's like a big blanket, it's making us a lot hotter. And at the same time, we're cutting down all the things that are our carbon sinks that that do that naturally. And so right now, companies are focusing on their ESGs, environmental and social governance, deeply tied to the business and funding. And we're offsetting. We're offsetting our footprints because we're not shifting the ways that we're creating facilities and we're operating those facilities. And that's where we have to start to focus. Carbon is found in the embodied carbon of a building. When we cut down a tree that sequestered all this carbon and we put it in a building, it's part of the carbon story. Reduces the footprint of that. And then in operations. So operational carbon is dealing with production of energy and energy use in a building. We have to focus on those two. And so if anything, start asking those questions. Where are my building materials coming from? What are they made of? Are they healthy for us? Are they healthy for the planet? And then how am I operating these things? When we don't do that, we get failures, right? We say buildings are doing one thing while they're actually doing another, and we're not following up to ask, is that the case? If you're gonna put a new air conditioner in your home, have you asked, is this operating as efficiently as it can? I don't know anything about air conditioners. I'm trusting that person that installed it to say, yeah, I got it tuned in right for you. So just ask questions. Lisa said it. Educate yourself a little more and tie into that carbon story, especially here in Florida.
Okay, and Lisa, you want to add?
Yeah, and just add to that the life cycle cost. So sometimes we look at things and we're like, oh, this is a great solution, but you're trading one thing for another, right? So we just have to look at the entire life cycle of all the components that go into the building and where they're going to go afterwards. Recycling factors and solar is something I'm just very learning a lot about right now. So my impact, also where I'm sourcing materials, so that's a huge thing that we've learned recently. Unfortunately, there was a lot of child labor being used in the production of solar panels. That's a huge impact that we're having, thinking we're saving the world, but yet there are things that we're doing that are causing harm. So just being very intentional with everything you do and just looking at the full life cycle of it.
Okay, anybody else want to add?
I would just add one quick thing, and that's budget for it, to do those assessments, monitor that performance, to do retro commissioning and keep those buildings continually running at peak performance. It does take that investment. So do it up front and make it matter.
Okay, I think we have time for one more, and I had to interrupt Philip Ferry when he was talking about how is solar incorporated into high-performance buildings. If you want to add to that, and then if anybody else wants to, if a homeowner said, I would like to put solar on my roof, where's the first place I should go to look? Because I see a lot of stories on the news, not just ours, where people have picked the wrong person to do that on their roof. So I'll first start with Philip Ferry, and then if we have time, we'll go on to that second question.
Okay, I kind of said this in the 15-minute lightning round, but efficiency first, always, efficiency first. And then, you want to install renewables on your home if you have a way to do that. And there's lots and lots of good companies out there, but kind of do your homework and make sure that they're not a fly-by-night organization and that they can provide the full service that you're looking for. I happen to have a net zero energy home essentially, and so I have solar on my home as well. And it's a wonderful thing. I have a power company bill every month that's exactly the same thing because I don't use any utility power, at least not right now. And so, please do it. Get to net zero if you possibly can.
Okay, anybody else want to add? Resources, homeowners who would like to go
Yeah,
solar?
so a big resource is the Solar United Neighbors. They're a great resource for everybody wanting to do solar. They're non-biased. We just won the Orange County Co-op, which if anyone lives in Orange County, they can join that co-op as well. We will be the provider for that co-op. But those are resources. It's really gathering your resources as homeowners. So the Solar United Neighbors really provides people an opportunity to come at it, installers, and do a competitive bid and then go in at volume, so you're getting a discount. So it just makes it really nice for homeowners to be able to get that same discount that maybe a commercial building would get, being a huge volume all at once. And then also Solar United Neighbors is really good about being diligent about vetting the company too, so you can feel good about that as well.
All right, Philip, real quick.
Real quick, I know we're out of time, but we live in a hurricane-prone state, right? Beware of the knock on the door. My neighbor was sold something and he was told, you will have energy when the power's out for everybody else, and that is not the case, and he did not educate himself, and he was shocked when I, who am not a solar installer, but I play one sometimes in my projects, told him, here's how it really works. So there's a lot of misinformation out there. Solar United Neighbors is a great resource, others to really do your homework.
Okay, all right, thank you. And I do want to add, I mentioned that there are some bad actors out there, but there's a lot of good actors, and it's nice that we have the good actors that head us in the right direction. And I want to make sure we have those resources available. So anyway, it's time for question and answer. We're out of time for the regular portion. So the mic to my left is open for members to come up and ask questions on the panel. Pat Grierson is at the mic to assist, so please line up to ask your question.
My name's Adrienne Katz, and I've read something really interesting, and I want to know if it's the truth, that there are windows that can generate electricity acting as solar panels. Is that true? Is it futuristic? Or that'd be cool if it did.
It is true, but they are very much in the research stage on these windows. They're not really on the market very much to speak of, but it is possible, and there are some out there.
I would just add to that too. If Philip hit the nail on the head, and we deal with this all the time, is when I see a new product, I always ask, how long has it been in operation? How long has it been out in the field? What's the warranty length? So there is new technology. We have to embrace it, but we got to make sure it works too. So.
Okay. My name is David Bottomley. I have lived in Orange County since 1969. I'm a USAF veteran. My field was refrigeration air conditioning up until about 30 years ago. So I have 24 years in HVAC, service, commercial and residential, plus 7 years in building automation systems. The outfit I was working for was putting in controllers for Sears and Kmart, and we found that 3 months out of the year, they could cool the entire 250,000 foot store. And this was a Sears store in the Florida Mall with fresh air. So my question for you is, where are the rooftop systems coming from? Are they being integrated into the building automation systems to be able to go multimodal? I have seen that work. Also, for the whole panel, I just looked it up here a minute ago, the 2023 building code for Florida is in draft form. What kind of changes do we expect? Because there's also, I think, ASHRAE came down with ventilation changes. ASHRAE is the American Society of Refrigeration and Air Conditioning Engineers on ventilation, because they found the buildings were being too tight, making tight building syndrome. So now we have, in the case of schools, you have to monitor the CO2 in the building to bring in fresh air. And like you said, Philip, Mr. Donovan rather, you have to go ahead and dehumidify that, treat that air first before, as it comes in. Like old refrigeration men never die, they just lose their charge. And frankly, on the residential side, I am waiting for propane to come in as a refrigerant, because the pressures are equal to that of R22, which is not a green gas, but it's not as highly pressured as the newer refrigerants are. So if you just address the Florida energy, the building code changes for 2023, that would be the key.
Anybody want to answer that?
Yeah, building code changes?
Yeah, sure. The building
code
code changes, we're still exploring them, and then it'll be up to each jurisdiction to adopt certain portions of those. But we got to be pushing for the highest level of ASHRAE, right? So Florida's predominantly been behind in that, and so we got to hit the legislation at the state level to push forward the higher level ASHRAE standards. To your point too, the best, we try to remove our HVAC units, our conditioning units from the roof, right? We want to optimize the roof for solar. We also want to make, so we're going to something, Florida, AC is cheap. We put rooftop units up, we replace them. When, Philip was talking about it as well, we have to balance it. You talked about the tightness of buildings, so we have to ventilate. And we've embraced systems that are dedicated heat pump, right? They're heat pumps, So when we put them in a school, we put them in and they serve 1 to 2 classrooms. So if that system goes down, you lose 1 or 2 classrooms instead of a whole wing that's on its own. But we also have dedicated outdoor air systems. So on days like you're talking about, where it's nice outside and we can just bring in fresh air and dehumidify it, we do that. We shut the mechanical systems down, and we monitor those CO2 levels. And in fact, in schools, we put in a little green light in the classrooms, and we get everybody involved. And what we found is when that green light goes on, it says, it's optimal conditions outside for bringing in fresh air. Those kids pester the teachers until they get up and they open the windows, right? Because it becomes part of the daily life. And this next generation, these kids are going to demand it. It's going to be part of their everyday lives, and they're going to demand a change. So we need to press to make the codes better. They've always generally been behind where not even the bleeding edge, just high performance really needs to be. So it's coming and it's speeding up. It's definitely faster in other states. So we need some lobbying and some advocacy to move that ahead.
We'll talk shop later.
All right.
I did. Valerie Schultz, Seminole League. In my 40-year-old house, I'm sure the air ducts are not optimal. My husband was just looking for a blower door test, someone to come and do that, and he was having a hard time finding someone. Is that the best test to assess your air ducts, to assess the viability of your air ducts? Thank you.
So we do that at 15 light years, so we can come to your house and do that. But it would be an integrated test with that and just doing a whole home energy audit, looking at the entire home, not just the duct work. And you should be there. I encourage you to be there when it's being tested because it's very informative. When we set up a blower door test, we depressurize the house and you can actually feel where the air leakage is happening. So whether it be your windows or your lights, your can lighting is another huge leakage area. So you can learn quite a bit from the energy audit test. It's not just looking at your appliances or anything like that. Another opportunity for us to come out and just kind of educate you and give you the low-hanging fruit.
And you work in Seminole County too?
Yep, we do. Our building's in Longwood, so we're not too far.
Hi, I'm Cindy Schleier, Orange County League member. And it seems like all the buildings are half parking lot, half parking garage. And I was wondering what can be done to address so much of everything is now just about parking.
You want to get that?
Everybody's looking at me. So within different, city and jurisdiction codes, there are typically parking requirements. They may vary within what's required for a downtown core versus a peripheral area. So it's, certainly something that could be up for discussion and up for revision, what that looks like. I think it is something that, we'll probably be grappling with as a city. How do we continue to grow? How do we grow densely in the right ways? There's obviously a lot of changes in patterns around car ownership and what younger generations want. And so I think there's things like that we think about our master planning, both for our downtown and then surrounding areas, and how we make sure they're connected, that warrant some, revisiting of what some of that might look like now. But yeah, parking minimums are there, and so that typically is a reason for why, lots and garages include what they do for new construction.
So I talked about what are we all willing to do personally, Cindy, and public transit, right? It's hard. It's going to be harder for us to move in that direction, and it's especially hard in Florida where it's harder to access and it takes longer to do, right? It's just so easy to hop in your car and go someplace, but we need to start thinking in those directions. We need to embrace those kind of ideals on a large scale, but on a smaller scale, there are ways to move around this. So there's places that will find efficiencies. When we worked on a church project, for instance, that was right near a supermarket. We worked with that jurisdiction to reduce the amount of parking we required because it was 2 different times that they were using those buildings. And so there was already all this parking there from the supermarket. So there was a lot of efficiencies we can pick up if we start to ask questions.
All right, thank you. We have to close, but there will be more discussion later, so we can continue then. I apologize. All right. I think we're moving on now. Is that correct?
No, I think we...
Okay, yes. A firm yes.
Okay.
Okay, so we're going to close now. Just please stay seated for announcements from Jennifer Adams. She's the second vice president. Thank you.
First off, thank you to our amazing moderator and panelists for being here, the work that you do in our community and sharing the knowledge and insights with us today. So really, honestly, thank you so much. Great discussion. And how appropriate for us to be here conversing and learning at a community event space adjacent to our public library. I hope each of you have learned or heard something new today about why this topic and having community conversations like this to share our knowledge and perspectives are so important and impact every single one of us, whether we realize it or not. In the final analysis, it seems that no matter the issue, it amounts to the intersectionality and every one of us working and coming together to further this